if I'm going to write the equations of a quadratic function in standard form with the following characteristics, where it's got a vertex in quadrant 1, well, if it's a vertex in quadrant 1, that means the vertex occurs when my x is positive and my y is positive, and my x and y are represented by the h and k. And it opens up, which means that a also has to be positive. So, as long as I pick positive numbers, y is equal to 2 bracket x minus 3 squared plus 4, I know it's going to work. In the second one, it opens in quadrant 4, vertex in quadrant 4, and it opens downwards. Well, if it opens down, then a is negative, and if it's in quadrant 4, then I have a positive h but a negative k, so a and k are negative, and h is positive. So I'm going to say that I have a negative value for a. I'm going to have, I didn't mean to change that. I'm going to have a positive value for h, and I'm going to have a negative value for my k at the end. If the vertex is on the x-axis, then that means that the vertex is going to occur when y is equal to 0. Y represents, or it is represented by k in this case, so I know my k has to equal 0. If it opens up, a has got to be positive or bigger than 0. So if my k is 0, I just don't include a k value. I'm just going to say that y is equal to, well, positive a, so let's say 2, and then x plus or minus whatever, because there's no restrictions on what h can be in this case. If the vertex is on the y-axis, then x is going to have to equal 0, and x is represented by h in this case, equals 0. It opens down, so a has to be negative or less than 0. And I'm going to say that y is equal to, pick a negative for a, and h doesn't exist, which means I can leave out the bracket part because saying x minus 0 squared is redundant. It's going to be the same as x squared. And then it doesn't matter what my k value is going to be. So, applying this to example 1. The first thing is if I consider the graph of the function f of x is equal to 2 bracket x plus 6 squared minus 9. Well, then I can say that my a is going to equal 2. My h is equal to negative 6 because it's the opposite. And my k is equal to negative 9. If I state the coordinates of the vertex, well, it occurs at h and k, or negative 6 and negative 9. The equation for the symmetry is going to be x is equal to the h value, or the x value at the vertex. Does the function have a maximum or minimum? Well, in this case, because a is positive, then it's going to open up, which means it has a minimum. And the minimum value is going to be what the k value or the y value at the vertex is going to be. It's got a minimum of negative 9. For the domain in the range, my domain is going to be really simple. It's just x, where x, e, r. Keeps going to the left, keeps going to the right. no issues there. The range, I gotta be more careful with, the range is gonna be y, where in this case it's got a minimum, so y has to be greater than or equal to what the minimum value is, -9, where y(er). And if I'm determining what the y-intercept on this graph is, well, the y-intercept is when x is equal to 0, so the y-intercept is going to be when I have f of 0 is equal to 2 times 0 plus 6 squared minus 9. Or f of 0 is equal to 63. If I'm thinking about the number of intercepts, then the number of intercepts are either going to be 2 intercepts, 1 intercept, or no intercepts based on where the vertex occurs and which direction the graph opens in. So if I'm going to draw an example of all these, I'm going to have 2 intercepts if either I have a minimum that is less than 0, which means that I have a positive a and a negative k value, or I have a maximum that is greater than 0, which is going to be a negative a and a positive k value. I'll have one intercept, no matter if it opens up or down, if the vertex occurs on the x-axis. That will only ever occur if k is equal to 0. Because I need to have a y value of 0 at the vertex. Or I can have no intercepts if I have a maximum that is less than 0, which means that I have a negative a and a negative k. Or I have a minimum that is greater than 0, which is going to be a positive a value and a positive k value. So if I'm summarizing all of the characteristics that exist in here, then the coordinates of the vertex are always going to occur at h and k. If a is greater than 0, the parabola is going to open up, and the vertex is going to be the minimum point. If it opens up, it's got a minimum. The range of the function is always going to be y, where y is, if it's a minimum, greater than or equal to the value of k, where y(er). If a is less than 0 or negative, it's going to open down. It's going to have a maximum, and the range of the function is going to be y, where y is less than or equal to k, where y(er). The domain always stays the same. It keeps going to the left, it keeps going to the right. The domain is always going to be x, where x(er). And the equation for the axis symmetry is always going to be x is equal to the h value.